please welcome Edge Impulse's Chief Technology Officer and co-founder, Jan Jongboom.
So, I'm Jan, co-founder CTO of Edge Impulse. When we started this 5.5 years ago, I would never have imagined that we'd have 300 people here in the audience, and I don't know how many people here in the live stream. Really, really, really cool. And I think for me, the biggest difference with Imagine this year compared to last year is that we have so many of our customers that have gone out of their POV, POC, etc., to million-plus unit deployments. That is really cool. And they're actually willing to come here and talk about that. That is absolutely amazing. A similar thing, like we've been talking a lot about customers, but a similar growth we've seen also in our community. So this is the growth in projects over the lifetime of Edge Impulse. Since the start in January 2020, imagine 2021. 36,000 projects. That already sounded like a lot of projects. That's all real Edge AI use cases that people have been building on top of Edge Impulse. And now we're almost at 400,000. And this goes faster and faster every year, which is absolutely, absolutely amazing. We have over 150,000 developers on the platform now. Last year, I know that we've been talking about synthetic data a lot today. But that's not how the majority of data is being created. The majority of that is people actually going into the field and sticking sensors to real machines or taking their phones out to get pictures of anomalies, etc. You guys, basically talking to the whole world, everyone watching on the live stream as well, have done this a lot, 724 million times last year alone. And that's a growth of 200% over what we've seen in the year prior. It's pretty insane. And we see this in academia as well. So on Google Scholar, there's now 883 papers mentioning Edge Impulse. And there's about 1.2 paper per day being added to Google Scholar, which is insane. Like, so many researchers and people that are sort of trying to push forward what we can do with technology, actually building that on top of Edge Impulse. That is just, as a founder, that is absolutely fantastic to see. So we like to say everything starts with data. And those 724 million samples are amazing, but they're also really hard to collect, right? You need to go to an actual machine, like stick sensors into place. So this is why I think Gen AI is so incredibly cool, because it already, perfect. This is me with someone saw this and they said, well, this looks a bit like a mix of a young version of Zach and you. But it's amazing, right? Like 2 years ago, it sort of all happened in the last 2 years. All of a sudden, computers are good enough to create data based on prompts, so we can leverage that. So earlier this year, we've shipped synthetic data support in the studio. So this incorporates models from 11 labs and OpenAI at the moment, but with a flexible interface, so you can plug in basically any model, for example, from the super wide collection of models that are on Hugging Face, to add custom synthetic data sources in Edge Impulse. So you might say, well, I want to build a keyword spotting model. We've seen the example from HP Poly. I've seen how much work it is to collect keywords, to actually build a keyword recognition model, especially in 10 languages, as they've done. But now I can just say, give me Edge Impulse Imagine. Click Generate Data.
Edge Impulse Imagine.
Can we put the sound up a bit more?
Edge Impulse Imagine.
There we go. Awesome. And whereas for images, sometimes when you think about Gen AI models, it's really relatively hard to build a wide data set, something that's good enough to generalize. For keywords, we're actually in a state where I think you can get 90% of your data created, through a Gen AI model and actually get something that works really, really well. The work that we've done with 11 labs actually brings this to non-voice audio as well. So audible events like glass breaking. That is glass breaking. If you want to build a model for this, I don't think anyone is going to be really happy if you're going to smash 1,000 glasses just to train that model. So Louis, one of our DevRel engineers, has actually built a model that can detect glass breaking, all done on completely synthetic data. So if you're interested in that, go look that blog post up. All of this is live today. Anyone on a pro and enterprise tier in Edge Impulse can just try this out. So if you haven't played the synthetic data feature, go do that. I think it's really, really cool. Ivan already explained how we're using Omniverse much better than I could, but I want to say here, this is just a plugin. So this integrates really nicely and deep into your Omniverse environment for both data collection and validation of these models. Again, this is live, this is available. We've seen from Ivan already how you can use this to actually build real models that work in the real world. Really awesome. However, a lot of these synthetic data sources and also what we do in Omniverse are really focused on computer vision first, then maybe some audio second. But if we look at the wide variety of use cases that our customers and also the community are building on Edge Impulse, it's mostly on sensor data. And I don't want to skip over that. So we're working, again, within Omniverse to integrate Isaac Sim, which is a simulation environment for sensor data, to also get that integrated in the same way. So we've realized that if you're building a fall detection system, it's not so nice to push elderly people over 1,000 times to get the data that you need. So this is a place where we can much better do that in simulation. So this is actually what our Isaac Sim integration looks like. So we have a stick figure, and just like what Ivan showed in Omniverse, you can script this and say, well, I want these people to fall over or start in different positions. So let's start a scene here. Put the person in position. Once we're happy, we click play, and they will fall over. And we've mounted the sensor, virtual sensor, on their wrist. So when we're done with simulation, bam, in one go, now in Edge Impulse, with synthetic fall data, and we can start building real models on this. I think this is super powerful. We're working on the first version of this. Pentatonic, for example, is very interested in already using that, so I'm going to be verifying this with them. But hopefully later this year, this will be available for everyone, first on IMU data, but we're going to be adding other sensors and a wide variety of sensor varieties together with our silicon vendors to make sure that we actually have virtual sensors that map to the sensors you can buy in the real world. I think really, really cool. Now, I said that everything starts with data, and the data sometimes is hard to get, but that's not completely true. I mean, if you just point the camera here on the audience or outside, you'll have plenty of data very, very quickly. The problem is it's completely unlabeled. You can't do anything with that. So if we have a quick way of taking unlabeled data and just adding labels to that, that will actually get us a labeled data set much faster too. Easy. And again here, what we've seen in the last 2 years with LLMs is absolutely freaking amazing. During the Olympics, I just took one screenshot of a medal ceremony, and I asked GPT-4, I was like, hey, what's happening here? They got everything right. It's a medal ceremony for a sporting event. It's an orange jacket, so it's probably the Netherlands. There's water in the background, so I guess this is rowing. And like, it's really amazing. So how can we do that, right? We can't just take an LLM and put it on a small device. For the simple reason that why these LLMs are so amazing is because they're huge. Trillions of parameters. So if we want to run that on a device that has, well, even a big device with 8 gigs of RAM, that means that the only way we can get these models to work is by using a lot less parameters. And that means that you lose all of this magic. There's just less capacity in this. So where we do see a lot more value is having an LLM or other GenAI models to actually help us label data or attach metadata to data. Because that allows you to take in large swaths of unlabeled data and then have, for example, the LLM go help me label all of the data. And that way it can go from hours of unlabeled videos to hours of labeled video data and train stuff much faster. So an example is I have a lot of photos of Louis, and I say, is this person wearing a hard hat? If so, say hard hat. If not, not hard hat. And it finds the stuff very quickly, right? This is not a hard hat. It's someone with a bike helmet. So we've been doing a bunch of experiments over the summer already using this, and now we're integrating this into the product with AI actions. So this is the UI for it. So on the left, you'll have your prompt, and on the right, you have a subset of your data. And you can immediately see what, in this case, GPT-4o, will make of this. So it will propose changes. So on the photo with the bike helmet, it will actually propose a change, label, not hard hat. Doing this on a subset of data is key because it allows you to iterate very quickly over this prompt. You can quickly see, like, does this work? Yes, no, okay, maybe I change my prompt a little bit and go forward. So we do this for image classification data, but we're also going to do this for object detection data sets, which is traditionally much harder. So again, I can take a prompt here. So this is a data set that if you've been at Imagine last year, if you've been at Embedded World, you've seen it. Our washers versus screws object detector. This has been a pain in the ass to label because this data set has 800 images, and all of these images have like 5 washers or 6 screws, and drawing bounding boxes around that is not fun. And we've done it by hand. But now we can actually use a transformer model, a zero-shot object detector, to help us label that. So I might say, I want to have all my washers, I want to have all my screws, and then it still misses a whole bunch of objects. So you can say, well, everything a circle with a hole in it, that is actually also a washer. And on this subset of the data, that actually works really well. So now I have my prompt. I click Label Preview Data. And instead of manually labeling all of these 700 images, which takes hours, now I have a perfectly labeled data set in a few minutes, which is really cool. And we can do this also for non-vision stuff. So here, for example, I say label all the speech sections and label all the music sections in my data set. And as you can see here, that highlights that straight away. So this is coming super soon. It's currently living on a branch on my computer, but coming to the Edge Impulse Studio probably in November or something. And again, this is completely pluggable. So if you have if GPT-5 comes out or Llama 17 comes out, we'll have a flexible API to plug in. So as these models get smarter, the integration within Edge Impulse gets smarter as well. And this is also not limited to just labeling data. We can actually use this for something that maybe is even more useful, which is adding metadata to stuff. Because you might say, well, my model is 98% accurate. Well, what does that mean? Where does this 2% come from? And this is actually where an LLM can help a lot. Why don't you use an LLM to add metadata to all of your data samples? And then we can slice your data by each of those metadata keys and give you really accurate descriptions of, hey, actually, your model is underperforming on data that is shot outdoors versus indoors. This is stuff you needed to do by hand before, but we're integrating all of that into the Edge Impulse Studio going forward. So you can get these insights and, hey, what is my model good at and what is my model bad at? The second is for checking whether labels are correct and general data quality issues. Are my pictures blurry? Are my bounding boxes actually properly aligned on my data set, like you can see here with Matthijs? This stuff, really useful. All of this is coming to AI Actions, and it integrates nicely in the rest of the product. So you can set up workflows like fetch all my data from S3, put it into my project, feed it through an automatic labeler, and then have an LLM do the data quality check. And after that, on all the good data, I retrain my model and push it back to the device. So now you have a fully automatic active learning loop, which I think is really, really cool. All right, so that was data. What can we do with the data? Well, build better models. So we shipped Impulse experiments a few months ago. This has been one of the fastest pickup of new features that we've ever seen in the product. And it allows you to do different combinations, different impulses, different combinations of DSP blocks and learn blocks in a single project. And it means that it's really easy to compare. So questions that you can answer this way is, if I downsample my data to 20 hertz from 100 hertz, how much does this actually affect my model performance? How much faster does my model get? And with like one click, you can retrain this when new data comes in. So this is live already at the moment for everyone. We're continuing the work here by launching a new version of the Eon Tuner that integrates really deeply in here. So the first feature that we're adding is Bayesian search. So right now, the Eon Tuner uses a grid search methodology. So if you have 100 combinations of options, we're going to search through well, maybe 50 models or something at random, and we give you the best combinations. Now we're going to use a Bayesian algorithm, and it means that the search space can be much, much wider. It also means that everything that we do will integrate into this impulse experiment list. So if you've constructed an impulse yourself, so you've constructed an ML model yourself, you can really easily compare that to stuff that the tuner has found. And if you see something promising, but you think, hey, there's actually more to it, maybe I want to go test it. This looks like a promising model, but I want to go see if the value of my filter is actually correct. Okay, one click, specify what parameter you want to tune. The Eon tuner runs, and you get all of those added to your impulse list. We've also been adding a ton of stuff for time series data. It's really easy to forget, right? In this whole day of talking about Gen AI and images and LLMs and whatever, they're really good at these images. We like time series data, so we've added early this year multiple labels per sample. So here you see the grind cycle or something of a coffee machine. You don't want to split this up into windows before you add it to a project. You want to see the complete cycle and the state changes of the label. That is supported now. We've added state to DSP blocks. So if you have a DSP block that needs to know what happened in the frame before, for example, because you're using a rolling mean or you have an adaptive filter, you can model it in the studio. We're heavily doing this internally for a heart rate variability block. And just last week, we shipped pre-processed and tabular data. So if you do your feature engineering outside of Edge Impulse, or you have data that doesn't fit our time series component so well because it's radar or something, you can just add tabular data. And it looks like this. As we announced last year, we've also now shipped a heart rate and heart rate variability block. So this takes PPG or ECG data in and outputs really high quality heart rate and heart rate variability features. And we do some really cool tricks like motion artifact removal. It's relatively easy to get a heart rate from a PPG signal if your arm is not moving. But once you're running or you're doing some activity, this data becomes super noisy. So we counter that by actually using the accelerometer data to denoise that signal. All of this you'll be able to model within the studio really soon for everyone. It's currently only for select customers. We're going to open this up for everyone. So you can just add your PPG data to a project and go model stuff right within the studio. And this is, for example, what we already have in production with UltraHuman today. All right, so on the new model side. So we've added over 100 new model architectures for computer vision with NVIDIA Tau. Really cool, available right now. We shipped FOMO-AD last year, a visual anomaly detection system. We have really cool demos in the demo area. And we've added, I think a lot of people have missed this, but we've added support for classical ML algorithms. And I realized that in this world of edge AI, we're thinking about deep neural networks, transformer models, but there is a huge place still for classical ML algorithms. If you do a lot of your pre-processing in the DSP step, you can have a very small network at the end. This is fully supported in Edge Impulse now, so you can both train and deploy models like LightGBM, XGBoost, random forest classifiers, etc. So that's really cool. But we're adding a couple of new things. So the first one is a high-definition version of FOMO-AD. And we've built that because FOMO-AD has been built for small devices, really constrained devices, microcontrollers, for example. And that means, because we have very small capacity, that sometimes something that is very obvious to us, people, is missed by FOMO-AD. So here we have a sensor with 4 pins. And if I train FOMO-AD on this and then give it a test image with only 2 pins, because FOMO-AD works on a grid, very thin objects cannot be flagged as anomalies. So in FOMO-AD, so actual anomalies are highlighted in white, so you don't see any anomalies here. So FOMO-AD thinks this is fine, whereas it's obvious that there's something missing in this image. So HD FOMO-AD adds 4 extra backbones and actually 1 additional scoring function. So it now comes in 10 configurations. So we can choose a higher capacity model if the low capacity version of FOMO-AD is actually not working. And FOMO-ADHD, as I wanted to call it, but that was not allowed, happily finds the 2 missing legs here. And even cooler, so we had this demo project, and then Alessandro, our head of products, said, hey, I have this test image in the data set, and I think something is broken in the model, because this clearly has 4 legs, but it was still flagged as an anomaly. This is actually the output of HD FOMO ID. So I went to look at it and realized that it actually spotted that the text on this sensor is actually squished. So it even finds stuff that is there's such a small change here. So I think with like this higher definition version of FOMO ID, we can detect these kind of anomalies really, really well. So FOMO ID now scales from 35K parameters, so that runs on relatively mid-end MCUs, to 8 million parameters, so now you're looking at MPUs. So again, coming soon, there is I think a little sign-up thingy if you want to have early access to that. We've also been working on a higher capacity object detection model with YOLO Pro, which actually is state-of-the-art object detector, completely designed from scratch for edge devices. So this is sort of, we have FOMO on the high-end MCU side, which outputs centroids. That's great. If you want bounding boxes, YOLO Pro is going to help you. And because we are not limited to trying to find an architecture that works well on Coco, we can actually make some other choices in the architecture of the network. And if you look at, let's say, a high-end industrial use case, we've seen similar performance as YOLO V8, but at like 5x less parameter count, which I think is really interesting. So we do some stuff in the way that we do the detector heads differently. Come talk to me during the happy hour if you're interested in how this stuff works. Again, this scales from high-end MCU. So if you have a high-end MCU that currently is able to run FOMO, but now you want bounding boxes as an output, you can actually use the low-capacity version of YOLO Pro. To that, this scales all the way up to high-end NPUs. Again, if you're interested in early access, scan that QR code, fill your details in, and we'll be in touch. And then I think something that I sort of am surprised that I missed this when I built the first version of Edge Impulse, application behavior. So when you train a model today in Edge Impulse, we give you a trained model out and probabilities come out. But that's not what you want in your actual application. Your ML model is just part of that application. It's a tool that you use to then make decisions. So there's some application logic after you get the probabilities. Let's say that you're building a smart wake-up system, right? So you have a wearable, and I want to wake a person up between 6:30 and 7, but only if that person is in light sleep. I can train a model and then go pick the one with the highest F1 score for light sleep, and then write some application logic, say, oh, well, if I see 3 light sleeps in a row, then I wake this person up. Is that a good model? Is it not? I don't know. I want to be able to model the complete application. So with application behavior, we allow you to actually go write that logic and say, my evaluation criteria should not be what's my highest F1 score, but how often am I waking this person up while they're in light sleep? Yes or no? And everywhere in the studio, I can go optimize that. So in the tuner, I can say, go optimize for the highest percentage of time that I wake this person up at the right time. So the first release that we're doing is vision related. So it's an add-on for all object detection blocks, which adds object tracking, so tracking between frames, and object counting. So this is what it looks. So this is YOLO Pro with our object tracking algorithm and then a counter. So you actually see that we can track these objects frame by frame, and then whenever they pass the line, we actually count them. And if the box color stays the same, it means that we know that we're looking at the same object. We've seen that so many of our customers need something like this that we figured it's best to add it to the platform. But this is not all that we'll have. We'll actually have custom block support in the same way as we currently do for signal processing blocks to add that. All right, so on the deployment side, these are all the deployment targets that we've added, or vendors from which we've added deployment targets in the last 12 months, which is just insane. Like fantastic work by both our silicon partners as well as by our embedded team. Truly, truly, truly cool. You've heard from a lot of these people. One that I want to highlight here is our Docker deployment option. So if you have a Linux device that allows you to run containers, you can use a Docker deployment. And that actually also supports NVIDIA GPUs. So if you're running on a Jetson Orin or some other box that has an NVIDIA GPU and you deploy on Docker, you actually get full support GPU hardware acceleration built in there. And what we're announced today with Sedida, we're going to actually bring this to 100 plus more targets. So if you have an industrial gateway sitting somewhere and you want to deploy Edge Impulse on it, just do it on Sedida. You have full support, including firmware updates and remote configuration. Can I have 5 more minutes on the timer? So I know. Hold on. All right, so for the Eon compiler. So if one thing we've heard from a bunch of people, including Paul earlier today, if we're looking at, like, a lot of our devices are RAM constrained, memory constrained. We have enough compute budgets to calculate really big models. But now we're constrained on the RAM size. So what we've been building with the Eon compiler, which is our neural network compiler for general purpose MCU and general purpose DSPs, is actually optimizing for RAM usage. So if you compare to, let's say, a leading open source project, and you take this model, which is a FOMO AD model, in this configuration, it would take 746 kilobytes of RAM. If you compile it down with the Eon compiler, we go down to 625K of RAM. That's 100K savings. That's nice. But we now have the Eon compiler RAM optimized mode. And in there, we do some really interesting graph rewriting stuff, like, for example, splitting convolutions. I don't want to do very aggressive vectorization, because that takes a lot of RAM. That's something you do on targets where you have unlimited RAM. But now on these deep embedded targets, we say we split this up a bit more, so we can take this down to 322K RAM. And that means that models that previously didn't even fit on this target can now fit, or you can choose a smaller version of that same chip, and that just means money saved on the BOM. So you get this for free when you deploy your model in Edge Impulse. The Eon compiler also has classical ML support since this year. And we actually have tens of new operators and operator variants, including self-attention and transformer networks. So if you have a neural network and you want to run it on MCU or DSP, throw it through the Eon compiler. Most likely it will just work. And if it doesn't, just go tell us and we'll add support for you. All right, 3 more minutes, or well, say 5 more minutes between me and the beer. So I want to talk about one more thing. This graph has been in our slide decks since the beginning of time. You have an edge device, you collect your data, you design and test and deploy, but then it starts all over again, right? After deployment, you collect more data, you retrain the model, and this is a continuous loop, an active learning loop. This last part, this part was always left to the customer. We always say, well, we output math, and then you put it on device, and from that moment, there's no connection anymore with Edge Impulse. We figured that if we really want to have these active learning loops, we need to have a way back of getting data from the device and feeding it back into your project. So for that, we started work on model monitoring. Zach talked a little bit about it earlier today. This is a feature that allows you to monitor devices in the field. We'll have inference statistics and firmware updates. And we'll have historic model predictions. So you can go back in time and say, someone flagged that at 2 p.m. yesterday we've had some errors. OK, awesome. Let me scroll back to what happened at 2 p.m. We asked the device, like, do you still have the data in your circular buffer? Yes, I do. OK, here it is. And I can relabel that and push that back. As I don't want to be building a device management platform, done that before at ARM. That was not fun. We're doing this together with partners. So we're rolling this out with Sedida and with AWS later this year, or maybe Q1 next year. This is what it looks like. So in your devices tab in Edge Impulse, you'll now have all of your devices, also if they're running inference. So this device is running inference for Jan versus not Jan, a simple image classifier. And on each of these, I can ask for a debug stream. So we never stream data back unless we click the button, and you see me, and that is indeed Jan. If I now want to have a model update, I can say request model update, and now we actually push a YOLO Pro version to the same device. And when I click the button, now I've gone from a simple image classifier to a bounding box detector that can detect me. So live debug streams, firmware updates in one go, one click, directly in the studio. I think really cool. And one thing you can do with this, like once you have this stream back from the device, you can also do stuff like model cascades to the cloud. So LLMs have this sort of zero-shot understanding, right? I can throw any random picture into ChatGPT, and it will tell me what's happening. But I can't do that all the time, because I'm going to burn through my battery in half a day, or probably even less, and I'm going to burn through my credit card at an even faster rate. So it's rather do local inference, right, which is super fast and cheap, but then I only can find out stuff that I've actually trained on. But if you combine these two things, I think it's best of both worlds. So let's say I first trained an anomaly detector, trained only on pictures on the floor. FOMO ID will then pick up that there is something here. We can send that back over the model monitoring line, and then ask GPT-4 like what's happening, and it can actually give us insights like this is a yellow soccer ball, and that's what we communicate back to the customer. This is actually best of both worlds, right? I only need to train a very small anomaly detector that runs really, really fast on device, that doesn't, can run even on a coin cell, and then only whenever I see that there's something happening, that's the moment that I cascade out to the really big model, and we ask what's happening. And now we still get this really deep understanding of the real world, but at basically 1% of the cost and of the bandwidth usage. So this is what it looks like. Here's a little model cascade demo. So we have FOMO ID, and I throw a random object here. And it will only know that there's something anomalous here. When I enable the model cascade, we feed this back to GPT-4 in this case, and it sees a colorful toy for my kid. And when we're back, we just run locally because we don't see any anomalies. But when I add 2 more objects, it finds my beers. And I think that's really cool, best of both worlds. And given that I now see beer on the screen, I think this is a really good moment to stop and go drink beer in the other room. So.